Hey guys, next thing we're going to look at is specific properties of isosceles triangles. Now we've already said that these things have two sides that are congruent and two angles that are congruent. Before we go any farther, let's talk about how we mark sides that are congruent. So what I'm going to do is I'm going to take and I'm going to draw a line there and there on this triangle. Now what those lines represent when you see them on a diagram is that this side is going to be congruent to that side. So those two sides are the same length. Anytime you have matching symbols on the two, that's going to mean that those two are congruent. And we can do the same thing with angles. Typically what we do is this arc across the angle, and if you see that same arc on both sides, that means those angles are congruent. So in this case, that angle right there would be congruent to that one. Now what we're going to do is piggyback off of this and start looking at specific parts of an isosceles triangle, and I hope you have your hands all warmed up because there are a lot of different parts we need to discuss. So the first part we want to look at, we're going to just take a triangle ABC right here. You can see we name it by its vertices, A, B, and C. And the first thing we're going to look at are these two congruent sides. So side AB and AC are congruent. Those two sides are called legs. So in an isosceles triangle, the two congruent sides are called legs. Then we also have two congruent angles, and those angles are directly across from the legs. So if we take this side right here and look at the angle directly across from it, that angle and then the angle directly across from the other leg will be congruent. So angle C and angle B are congruent, and those angles are called base angles. Now one of the reasons we call them base angles is because the segment that is part of both of them is called the base, and this would be the side of the isosceles triangle that is not equal to the other two sides. So the two sides that are equal are called legs, the side that is unequal is called the base, and the two angles that are congruent are called the base angles. So just like the base gets its own name, the angle that is the odd man out gets its own name too. We call that a vertex angle. And you'll need to be able to identify all of these parts on a diagram of an isosceles triangle. So remember, legs are the congruent sides, base angles are the congruent angles, the side that is not equal to the others is called the base, and the angle not equal to the others is the vertex angle. So you need to know those parts of an isosceles triangle. You also need to know this kind of interesting fact. Let's take just the vertex angle here, and let's draw a line directly down through angle A in such a way that it cuts angle A into two equal parts. So we would call this line the angle bisector of A because it cuts it into two congruent angles. One interesting thing happens at the base of the triangle. So when we look down there, we see that this line, this angle bisector of A, is going to be perpendicular to the base. And not only is it perpendicular, but it actually cuts that segment into two equal pieces. So C to this middle part here would be the same distance as from the middle to B. So what happens is that the angle bisector of the vertex angle is going to be the perpendicular bisector of the base, and this happens in isosceles triangles, not in scalene triangles, but rather just isosceles triangles. This makes it a nice test. If we can prove that this is true, we've proved that the triangle is in fact an isosceles triangle, and in fact you'll see some of those cases as we move along through the course.